what we are going to start doing now is drawing our graphs. And you guys actually have to pay very close attention to what we're doing, because when you get to the test and quiz, you're not going to have your graphing calculator in front of you. And that's part of the reason, because of this stuff right here. You actually want to make sure you understand what all these pieces mean about the graph, and make you realize you don't have to have this graphing calculator, because our derivative tells us a lot of information about our graphs. The first thing on your handouts, you've got this little picture. And we are trying to decide what our derivative tells us about the actual graph. You know, if we are looking at this, if that blue curve here is my graph, and the pink represents the tangent lines, which we know the derivative is the slope of those lines. What's true about these lines right here? Right, those are all positive slopes, right? And our graph right there is increasing. Okay, now my graph's decreasing. What's true about these tangent lines? Negative slope. And then my graph starts increasing again. What's true about your tangent lines? Positive slope. So, whether our derivative is positive or negative tells us if the graph is increasing or decreasing. If your derivative is greater than 0, the original function is increasing. If the derivative is less than 0, your function is decreasing. I want to know where this function is increasing and decreasing. So if I don't have my calculator in front of me, I can find out where it's increasing and decreasing by finding out where the derivative is positive and negative. So first, let's do our derivative. So the derivative of x squared would be 2x minus 4. Okay, if you're going to find out where it's positive and negative, first you need to find your critical points. Your critical points are where the derivative is 0 or undefined. This is a polynomial. Will it ever be undefined? No. So if we just find out when it equals 0, that's when x is 2. Okay, so I know when x is 2, my derivative is 0. I need to know whether it's positive or negative on either side of that. So without looking at a graph to tell me, what we can do is pick some test points. For everything smaller than 2, it's always doing the same thing. It's either positive or negative. It's also true for everything greater than 2. So you just pick a test point. Give me a number smaller than 2, like maybe a 0, and something bigger than 2, maybe a 4. And what I'm going to do with those is plug them in to the derivative, because I need to know if the derivative is positive or negative. So if I put a 0 into my derivative, I get negative 4. So that means this whole section is negative. If I put a 4 into my derivative, I get 8 minus 4, which is a positive. So that tells me, where is my graph increasing? 2 to infinity. And it is decreasing from negative infinity to 2. So we did the derivative, found where it was positive and negative. Question 4. That makes sense to everybody. Let's do another one. I'm going to find where I'm increasing or decreasing. I need to know if the derivative is positive or negative. So our derivative would be 12x cubed minus 12x squared minus 24x. Again, this is a polynomial, so we know it's never undefined. Critical points are where you are 0 or undefined. So how will I find out where this thing equals 0? Well, we did our derivative. Set equals 0. What am I going to do there? First, the before box method, you need to pull out a 12x. Take out your greatest common factor. So then we can do our box method. Multiply -2 and add to -1, -2 and +1. So what are your critical points? 0, 2, and -1. This thing equals 0 3 times. When you make your sign line, you have to put those things in orders, left to right, just like a number line. Okay. Test points, so something smaller than -1. -2. In between -1 and 0, -1/2. In between 0 and 2, maybe like a 1. And bigger than 2, maybe a 3. We have to plug these into the derivative. You can put them in anywhere you want. I prefer using the factored form. It's just a little bit easier to me, especially if you're thinking about doing it without a calculator. If you put in -2, 12 times -2 would be a negative number. -2 minus 2 is negative. -2 plus 1 is negative. If you multiply 3 negatives, you get a negative. If I put in -1/2, 12 times -1/2 is negative. -1/2 minus 2 is negative. -1/2 plus 1 is positive. So negative times a positive. I put in a 1. 12 times 1 is positive. 1 minus 2 is negative. 1 plus 1 is positive. Positive times negative times positive. But I put in a 3. 12 times 3 is positive. 3 minus 2 is positive. 3 plus 1 is positive. So if you multiply those, you get a positive. Does everybody understand how we got those? So, you are increasing where your derivative was positive. We were positive here and here. So my graph is increasing from -1 to 0 and from 2 to infinity. We are decreasing where the graph was negative. Where's that? Make sure when you write those intervals, you're using the points, your critical points, not the test point that we made up to check it. Questions there? All right. This tells us more than just where the graph is increasing or decreasing. This actually tells us about our maximums and minimums. If your derivative switches from a positive to a negative, that means you have a local max. Okay, think about that. If the derivative is positive, that means your graph was increasing. Then if the derivative becomes negative, it starts decreasing. So if you go from increasing to decreasing, you just had a maximum right there. If your graph switches from negative to positive, so you were decreasing and then you switched to increasing, what do you have? A local min. If it does not change sign, so you find a critical point, but it's possible that when you test your critical point, you're positive on both sides of it, or you're negative on both sides of it. If that happens, if the sign does not change, then there is neither one. There is not a local maximum or minimum there, if the sign does not change. I just put some pictures up to explain that, but I already kind of mentioned those, so we're going to jump into another example. I want you to find our local maximums and minimums of this. You'll notice, since this is the same as example 2, it's the same polynomial. So if you look back at example 2, we already found where it was increasing or decreasing. So on your notes, if you just want to write, from example 2, or look back at example 2, you have to do all of this. And then we can figure out our local maxes and mins from there. We have to look at each of our critical points and what happened. At -1, my derivative was negative, so it was decreasing, and then it switched to increasing. What does that mean? That is a local min. Okay, different from absolute. When we did absolutes, we plugged them into, we had to test our critical points and endpoints. So I have a local min. When I put in -1, let's see what we get out if I put in -1 to the original. So -1 to the 4th would be 1. So we get 3 plus 4 minus 12 plus 5. What does that give us? 0. To get the y value, you put it into the original. Okay, at 0, my derivative switched from positive to negative. So it was increasing and then it switched to decreasing. So what does that mean? Local max. When my x was 0, if you put a 0 into the original, what do we get out? 5. Okay, I have one more point, 2. At 2, my derivative switched from negative, so decreasing, to positive. So decreasing and increasing, that means local min. So I have another local min. Okay, if I plug a 2 into this, 2 to the 4th, 16 times 3 is 48, minus 8 times 4 would be 32, minus 4 times 12, 48, plus 5, so those cancel, negative 32 plus 5 would be negative 27. I want you guys to try example 4. So I want you to find all of your critical points and decide if they are local maximums or minimums. get 3 and -2 for your critical points? So to decide if they are local maxes or mins, we are going to do our sign line. Okay, smaller than -2, maybe a -3, in between the two, and bigger than 3. So if I put in a -3, 6 is positive, -6 and -1, so that would be a positive overall. If I put in a 0, positive times positive is a negative. If I put in a 4, it's all positive. I didn't ask, but where is this graph increasing? Right, negative infinity to -2, union 3 to infinity. It is decreasing from -2 to 3. Okay, I asked for you to classify local maxes and mins. So if you think right here, this graph went from increasing to decreasing. So -2 is a local max. Okay, find your y values, plug that into the original. 2 times -8. $51. Okay, at 3 it went from decreasing to increasing, so that is local min. So if you put a 3 in there, 3 1/3 is 27, times 2 is 54. And 74. Is that what you guys got? Yes, sorry. Okay. Are you okay with those? Okay, I was going to stop here, but I think I'm going to go ahead and do example 5 with you. And then I'll stop for today. So same directions, classifying the critical points. So we have to do our derivative. Derivative of 4 is 0 plus, so it would be 1/3 x. 1/3 minus 1 is -2/3. Probably would help you to rewrite this. A negative just drops it on the bottom. A 2/3 power means the cube root of that squared. Okay, is this ever going to equal 0? If you set it equal to 0, you would multiply over the bottom and you'd just have 1 equal 0. So does that happen? No. Is it ever undefined? When? What would make the denominator 0? It's 0. So if you plug in a 0, you get 1 divided by 0, which we can't do. So we do have one critical point at 0 itself. Okay, so that's the only thing I have to test. So we need smaller and larger. If I put in a -1, 4 plus the cube root of -1 is -1. 4, sorry, I'm putting this into the derivative, aren't I? I'm not finding my y value yet. If I put in a -1 squared is 1. Cube root of that is 1. So you get 1/3, which is positive. You put in a positive 1. 1 squared is 1, cube root is 1, so you get 1/3, so it's again positive. What does that tell me? There is, we have no local max or min on this graph. Okay, so now let's talk about the next few days. What's going to happen. For tonight, you have a handout that I'm going to give you for homework. You are not going to turn in your homework to the sub. So that means when I get back Thursday, you are going to have several things to turn in to me. So don't give this to Seb. You'll give it to me on Thursday. Tomorrow, I am going to post a video on Classroom. It's just my video from last year for the next portion of the notes. Last year I only got through the first 4 examples, so it starts with example 5, which we just did, so you can just skip through that part of the video. And then we're going to start talking about the second derivative and what that means for the graph. I'm going to work, I think I stopped at example 9, so you'll fill in the next page and a half of your notes tomorrow. If you want to watch that video before you come to class, you can. I'll go ahead and post it after class today. Otherwise, bring your earbuds and watch that part and fill in your notes tomorrow. I think the video is about 25 minutes long, but like I said, we've already done one of the examples, so you can skip forward a little bit there. And then you will get a new handout tomorrow. The sub will give that to you. So today's handout is increasing, decreasing. This sub will give you one on concavity tomorrow. Wednesday is just going to be a work day. You are going to get a 3rd handout. So that means when I get back Thursday, you have 3 handouts ready to turn in to me. Answer keys are in the folder like always, so you know you can check those. Wednesday's handout is going to be graphing. So it'll be like 6 questions, and you are actually going to put everything together and graph. The notes tomorrow will get to that point where I start graphing things. So you should have all of your gaps filled in. And it's going to tell you in the directions exactly what I want you to find. You know, all the critical points. Where is it increasing and decreasing? Where are your maximums and minimums? That stuff we've done already today. Then I'll ask, tomorrow you'll talk about inflection points and concavity. So you'll take all that information and draw me a graph. I expect you to plot points exactly on there, so if you have a minimum at 2, -1, make sure you put your dot at 2, -1. I expect you to list out all the information, so if you turn it into me and you just have a graph and none of the work, you will get none of the credit. Okay, you have to find all of those pieces. So Wednesday will just be a work day for that graph handout and anything else that you have not completed to that point. If you are having any issues whatsoever, you know I keep the keys over there so you can check your work, help one another. If you need to, email me. I'm at a conference. I will have plenty of access to email you back. So email me with any questions or issues whatsoever. When I get back Thursday, we are still on this section. We will be finishing the last few examples and doing some more practice with this stuff. Okay, are there any questions about Mr. Henderson?